Okay, guys, hey there. You wanted to see number 24 from lesson 39, so let's go ahead and take a look at that one. It's on page 180 if you want to turn there to see the problem. Number 24 says, find the equation of the line that passes through the point 2, 4 and is perpendicular to the line that passes through 2, 4 and -3, -2. Okay, so we know first of all that, that we are going to be talking about a coordinate plane. We have some very valuable information about this. We have our x and our y axes, and I'm going to go ahead and put some little marks on here. If I didn't put a graph in yours, you may have to do this as well. Just draw one out. Now, the first thing I notice is I've got two lines we're talking about here. One of them I know is at 2, 4 on our coordinate plane, and -3, -2. And we can plot that line, okay? So that's one line. So we'll say that's line number 1. And then there's another line that passes through the same point, 2, 4. I don't know its other coordinate. We don't have that, so I can't put it on there. But what I do know is that these lines are perpendicular, okay? Which means that when they intersect, they're going to make 4 right angles at their intersection. Now, there are some relationships that we need to know about this. First of all, when we're writing an equation, which is what we're being asked to do, remember the equation for a line is the y-intercept format. Looks like this: y equals mx plus b. Now, the line I'm trying to figure out is this one right here, okay? So in order to do that, I need to figure out what the slope is, and I need to know what b is, because I can't write my equation without those two items. Okay, but I can figure those out. There is a relationship when you have perpendicular lines. There's a relationship to their slopes. And if you remember, back a few lessons ago, we did a problem similar to this, except it dealt with, you don't need to write this down, but it dealt with parallel lines. And we were trying to find the equation of one of those lines. So we had to find the slope of the first line. And once we knew the slope of that first line, then we knew the slope of the second line, because they're both slanted in the same direction. That one was easy. Those two lines have the same slope. But when you're looking at perpendicular lines, they don't have the same slope. As a matter of fact, it's completely the opposite. And what we call that then is its negative reciprocal. So if I can figure out the slope of line 1, then I can turn it over and make it negative, and I'll know the slope of our perpendicular line. So let's get the first line on our coordinate plane. We're going to plot 2, 4, and -3, -2. And I'm going to try to connect those as straight as I can. Not great, but it will do. And we're going to find the slope of this line. So you remember, we can find the slope by using rise over run. We start at one point, so we'll start at this point, and we're going to rise and see how far we have to rise to get to the second point on the line. So I would have to go up 1, 2, 3, 4, 5, 6. I would rise up 6 and rise over 1, 2, 3, 4, 5. Run over 5. So I rose up 6 and I ran 5. So my slope of this line is 6 over 5. Which means the slope of my perpendicular line is going to be its negative reciprocal. So the slope of this line is going to be -5, 6, because it's going in a completely opposite direction. Alrighty, now back to my blue pencil. Let's see what we can do to figure out how to write the equation of this line now. Okay, so I know the slope. I'm going to come down here where I have a little bit more space. I'm going to rewrite the equation here, or the formula rather. And I'm going to fill in what I do know. Well, the only thing I know about this perpendicular line is it crosses through 2, 4 on my coordinate plane. So I am going to use those to my benefit. I'm going to put them right here. And I'm going to mark this one X and this one Y. So then I'm going to substitute in what I have. I have my slope, which is -5, 6. I have X, which I'm going to grab from right here out of my set of points here, is 2. I'll put that over 1, plus B, which I do not know. Y happens to be this 4 that's in that set of points, and I'll put that over 1 as well. Now let's do a little math here. I can cross cancel here. Let me go to red, or orange rather. I can cross cancel right here for a 1 and a 3, which means now that I have 4 over 1. I'm going to change this to 12 over 3, and you'll see why in just a second. I want it to have a denominator of 3 because look what happened over on the right-hand side over here. I'm going to have negative 5/3 plus b. Okay, now I want to solve for b. I need to know that value. That value is actually the y value of our y-intercept in the line, and it's a very important part of our equation. So I end up with 17/3 is what b is equal to. So the formula, I'm going to write it in, or the equation of that perpendicular line is going to be y equals, remember it was mx plus b, so let's fill in our parts. We always leave y as y. We fill in the slope. We said it was negative 5/6. We leave x as x, and we put our b right here. Because remember, if I were to actually plot this onto my coordinate plane using this equation, I know that this is the y value to my y-intercept, and I would have that to be able to plot. And then, of course, the negative 5/6 is the slope, and I could find that from my y-intercept. But what we were to figure out here was just the equation of the perpendicular line, and that is the answer to that question. Okay, guys, I hope that helps. Thanks for watching.